We'll continue from where we stopped in the previous video. Please do well to subscribe to my YouTube channel so that you can watch more of my videos, okay? So we take it from question 26. Question 26 says that if we were testing the hypothesis HO mu equals, let's say mu sub 0 versus HA is mu greater than mu sub 0, where mu sub 0 is a specified value of mu at a given significant level alpha with large samples and unknown variance. It's a large sample and what? Unknown variance. Large sample and unknown population variance. The population variance is unknown. Okay. Then HO will be rejected if the computed test statistic is, since the sample is large, okay, you are testing for this if it's greater than, isn't it? Please, here the answer is A. You only reject HO if Z, when you compute Z, when you calculate Z and the calculated Z value is greater than the critical value of Z. Okay, when mu is greater than the mu sub 0, it's a positive or it's a right-tailed test. So since it's a right-tailed test, then Z should be greater than critical value of Z. Then you reject HO, something like this. When you have mu greater than this, it means that it's at this side, it's a right-tailed test. And for a right-tailed test, if this is the critical value of Z, then your computed Z should fall within the rejection region of rejection, before you can reject HO. So HO will be rejected only if Z is greater than what? Critical value of what? Of Z. Okay. Then question 27. An advertising agency would like to create an advertisement for fast food restaurant claiming that the average waiting time from ordering to receiving your order at the restaurant is less than 5 minutes. It's what? Less than 5 minutes. Now, the agency measured the time from ordering to receive delivery of order for 25 customers and found that the average time was 4.7 minutes with a standard deviation of 0.6 minutes. The p-value of the test will be. Now, to find the p-value here, check what type of standard deviation is given. You've been given a sample standard deviation. This standard deviation is referring to the sample. It's referring to the sample. So it's a sample standard deviation. And check the sample size. The sample size too is less than 30. So you should know you are using T. Okay. The sample size is less than 30. At the same time, the standard deviation is not a population standard deviation. So you are using T. So and the formula for T is sample mean minus population mean divided by sample standard deviation divided by root n. So what's our sample mean? Our sample mean is 4.7 minus what's our population mean? 5 divided by sample standard deviation 0.6 divided by root n, and our n is 25. So when you compute this properly, you should get negative 2.5. Okay, negative 2.5. So you go to your T table. Now, before you go there, you need the degree of freedom. Degree of freedom is equal to n minus 1, isn't it? And your n is 25 minus 1, it gives you what? 24. So you go to your T table. You have 24 here, right? You check the degree of freedom of 24, then you trace it. Then you check where you can get, you ignore the negative and look for 2.5. This is very close to 2.5, right? So meaning you are taking this place. Then you trace it upward. It's a one-tail test. So when you trace it upward, on it you get 0.01. So meaning your p-value is 0.01. Okay, your p-value is 0.01. So the answer is D. Your p-value for a t is, for this t is 0.01. So the answer is D. Then Question 28. They say at 5% level of significance, we can claim that the average time between ordering and receiving order is. Here, the answer is D. The reason is, your HO, or you have HO and HA, H sub 0 and H sub E. There is a statement of inequality here, less than, and it goes for the HA, isn't it? So the mean is less than 5, and HO is saying that, or H sub 0 is saying that the mean is greater than or equal to 5. So if that is the case, let's look at something. What was your p-value? Your p-value is 0.01, isn't it? And what's the level of significance? 0.05. 5% means 0.05. So you see that the p-value is less than the level of significance. There's a rule that whenever your p-value is less than the level of significance, we reject HO. So if we are rejecting HO, it means that we are supporting this. So we can claim that the time is less than, because we are supporting this, we can claim that it's significantly less than what? 5 minutes. So the answer is D. Okay, it's significantly smaller than 5 minutes. So question 29. When will it be reasonable to construct a confidence interval for a parameter if the values for the entire population are known? You know the value of the entire population. Let's say you are 4 in a room, and you want to find, let's say, the mean. Let's say 4 in a room, you get salary. You want to know the mean salary. You know the entire population, so it's easy for you to get the mean of the entire population, isn't it? You can easily get the mean of the entire population. Are you getting it? So the question is asking that when will it be reasonable to construct a confidence interval for a parameter if the values for the entire population are known? The entire population is known. So you can easily find the mean of the entire population. So why are you constructing confidence interval again? We only construct confidence interval when the entire population is not known, and we want to estimate what likely the entire population mean would have been. So the answer is A. Okay, 29, the answer is A, never. We are not going to construct a confidence interval when the entire population are known. Then question 30. It said a calculated numerical value that is compared to a table value in a test, in a hypothesis test, is called. The answer is D. It's a test statistic. Okay, when you calculate Z, like here, let me take it. When you calculated this T is called test statistic. When you also calculate for Z somewhere here, there was a place you calculated Z. When you calculate Z, it's also called test statistic. Okay, yeah. So the calculated value is a test statistic. Okay, so the answer is what? D. The calculated numerical value that is compared to a table value, the value you get on the table, which is a critical value, is known as a test statistic. Okay. Now, question 31. A right tail test is performed with a test statistic having a standard normal distribution. If the computed test statistic is 3, the p-value for the test is. Now, to do this, the question says if the computed test statistic is what? Is 3, meaning that if, let's say, if Z is 3, that's 3.0, right? 3.0. We should find the p-value. And the question also says if it is a right tail test. So right tail test. So let's see. Sorry for my bad drawing. So right tail, meaning we should find this side. And you have 3 here. Let's see what to give us. Let's find the area to the left of 3. 3.0. The area to the left of 3 is 0.9984. This 0.9984, isn't it? 0.9984. 3. 0.9984. 0.9987. Okay. So meaning this side is 0.9987. So to get this side, you say 1 minus 0.9987. It gives you what? It gives you 0.0013. So the answer is C. Okay. Then 32. It said new software is being integrated into the teaching of a course with the hope that it will help to improve the overall average score for this course. The historical average score for this course is 72. Now, if a test statistic is done for this situation, the alternative hypothesis will be, is that is the historical is, I getting it? And when you look at it, it said, look at the question again. It said new software is being integrated into the teaching of a course with the hope that it will help improve. So this improve means that it will help you to be greater than 72. And greater than is a statement of what? Inequality. So meaning your HA will be what? P greater than 72. Improve means it's greater than, it has increased. So it's the improve that will help you get the answer for this. So the answer is D. 33. A type 1 error is defined to be the probability of. A type 1 error is defined to be the probability of rejecting a true null hypothesis. When the null hypothesis is true, okay, and you reject it, HO is true, and you reject it, it's called type 1 error. Okay. But when you fail to reject it, when you do not reject it, when you fail to reject it, you've made the right decision or justice has been made. Okay. But when HO is false, when HO is false and you fail to reject HO, it is false, but you fail to reject it. It is type 2 error. But here, type 1 error is the of rejecting, when you reject the null hypothesis when it is true. So rejecting the true null hypothesis is type 1 error. So the answer is what? D. 34. In a hypothesis test, the level of significance is the probability of. Now, type 1 error is also the level of significance. Okay. Type 1 error is also the level of what? Significance. Okay. So if type 1 error is the probability of rejecting a true null hypothesis, then level of significance will be the probability of rejecting a true null hypothesis, the maximum probability of rejecting a true null hypothesis. Okay, so the answer is what? It's also D. Then 35. For the following information, n equals 16, mu equals 15, sample mean equals 16, and variance. Whenever you have this square, it's known as variance. But whenever you have this without a square, it's known as standard deviation. So be very careful about that. Okay. So we've been given a variance. This is a variance. Okay. Now, assume the population is normal. If you are performing a right tail test for a single population mean, then the p-value is. So to find the p-value, we've been given a population variance or population mean, so we are finding z. The population standard deviation is known, so we are finding z. So we have 16 minus 15 divided by, we have a variance, so to convert it to standard deviation, it will become square root of 16, okay, divided by root n. And our n is what? 16. So 16. When you fix this on your calculator, you get 1, isn't it? And the p-value means that if, let's say, 1 is here, and it means it's a right tail test, right? Because it's a positive value. So we should find the area at the right tail. That's the meaning of the p-value for this. So to get it, you find the area to the left of 1. Area to the left of 1 is what? 0.8413, right? So when you get the 0.8413, you subtract it from 1. So you say 1 minus 0.8413. It gives you what? 0.1587. So the answer for this is C. The p-value is 0.1587. So let's quickly come here. 36. We have been given the same data again. And it says if you are performing a right tail test for a single population mean, then what will happen? A. We'll reject the null hypothesis if alpha is 0.01. Here, not to waste time, the answer is B. That's the only reasonable thing there. Question 36. The reason being is that I'll use two things to prove it for you. Okay. Let's see. The first one is that let's say the level of significance is 0.1, right? What was the p-value? The p-value was 0.1587 and the significance is 0.1. How will you describe the relationship between them? You will say what? The p-value is greater than the level of significance, isn't it? And according to the decision rule, whenever the p-value is greater than the level of significance, what do? We fail to reject the null hypothesis. So at 0.1 significance, we will fail to reject the null hypothesis because the p-value is greater than the level of significance. Okay, so the answer is B. Another way of checking it is you sketch a curve. Okay, so our computed z was 1, right? Then we find a critical value of z. To find a critical value of z, you subtract the significance 0.1 from 1. When you subtract it from 1, it gives you what? 0.9000. So you look for 0.900 here. So we search for 0.900. So we have 1.28. This is closer to 900. This 8997 is closer to 9000. So we have 1.28. Okay. So 1.28 is your critical value. What we got in 1.28 is you take this and the top here, 1.28. Okay. So if we should plot 1.28, it will fall at the region of what? 1.28 will be somewhere here. So this is the critical value. This is the critical value. 1.28 is here and 1 is here. You realize that the computed z value doesn't fall in the region of rejection. It is the critical value that cuts or that separates the region of rejection and the region of acceptance. So the computed z is not at the region of rejection. Okay, so we are not going to reject HO. So the answer is B. So this is the first proof and this is the second proof. But just if you know this, just use this and go. Okay. Yeah. 37. We are given the same data again. We've been given the same data. They say if you perform a left tail test for a single population mean, then you. Now here the answer is A. You reject the null hypothesis if alpha is 0.2. The reason being is, what was your p-value? Your p-value is 0.1587. So 0.1587. And if alpha is 0.2, then compare it. You realize that this is less than, the p-value is less than alpha. Whenever p-value is less than or equal to alpha, we reject the null hypothesis. But whenever p-value is greater than alpha, we fail to reject the null hypothesis. So looking at this p-value is less than this alpha. Okay, so we have to fail to reject, we have to reject the null hypothesis, sorry. Okay, so the answer is A. Then 38. Find the standardized test statistic Z for the following situation. Find the standardized statistic Z for the following situation. We've been given P to be not equal to 0.23, then X to be equal to 52, and N to be equal to 200. Now to solve this, we are going to find the value of Z, isn't it? Yeah. Now, this is a proportion, so it's going to be what? P hat minus P, isn't it? Divided by the square root of P times Q over N, isn't it? So, what is our P hat? Our P hat will be X divided by P hat to be equal to X divided by N, which is 52 divided by 200. 52 divided by 200 gives you what? When you put it on calculator, you get 0.26. So you substitute 0.26 here, minus, what's your main P? Your main P will come from the claim, which is 0.23, divided by square root of P times Q. What's your P? Your P is 0.23 times, your Q will be 1 minus P, which will give you 0.77, divided by N, and your N is what? 200. So when you fix the whole of this on your calculator, you should get 1.008, 1.008, which you can approximate 1.01. So that makes the answer B. Okay, the answer is B. Then let's see question 39. It says find the critical values for a two-tailed test where alpha is 0.05 and n is equal to 8. So to do that, you find degree of freedom. Okay, you find degree of freedom. Degree of freedom is n minus 1, which is 8 minus 1, that is 7. After getting it, please take note, they said two-tailed test. Okay, two-tailed test. Now what's our alpha? Our alpha is 0.05. Okay, so you go to your T table. Okay, now our degree of freedom is 7, isn't it? So 7. And our alpha, they said two-tailed test. Our alpha was what? 0.05, isn't it? So you go to where they've written 0.05 at two tail. Check two tail. Where they've written the two tail. So 0.05 is here at two tail. So when you trace it downwards towards the degree of freedom of 7, you are going to get this 2.365. Okay, 2.365. If you feel like checking it at where they've written one tail test, then you have to divide the alpha by 2. The alpha, you have to divide it by 2. That's 0.05 divided by 2. It will give you 0.025. When you check it at where they've written one tail test, one tail, you still get same answer. Okay, so be very careful. The question says two tail. Okay, so you just go and check the 0.05 at where they've written two tail test and trace it to your against your degree of freedom. Or you divide it by 2 before you check it at where they've written one tail. Don't go and check 0.05 at where they've written one tail. You'll get it wrong. Okay, so the answer is what? 2.365. 2.365. But it will be a plus or minus because it's a two-tail test. Okay, so plus 2.265 or 365. Yeah, 365. Yeah, 2.365. So there is a typo here. The answer is D. This was supposed to be negative 2.365. So the answer is D. Okay, there is a typo here. Don't mind that. The answer is D. Then question 40. If a null hypothesis is rejected, at a 5% significance level for a right tail test, you now here the answer is A. The reason is that let's look at something. At a 5% significance, so let's 5% means 0.5, right? 0.05 significance. 5% means 0.05. So at 0.05 significance, for a right tail test, what will happen? Let's check D to B and see if it makes sense. They say we'll sometimes reject it at 0.06 level of significance. So at 0.06 level of significance, meaning maybe it was here. Okay, let's consider this small. Let's come here. They say we'll always not reject it at 0.01. 0.01 would have been somewhere here. You will still reject it at 0.01. Any significance which is lower than this significance, you will always reject it. Okay. Then B also say we always reject it at 0.01 significance. Yeah. If you are rejecting at 0.05, it doesn't necessarily mean that you reject it at 0.01. No. But if you are rejecting something at 0.05, definitely it means that even at 0.1, you can still reject it. Okay. If you are rejecting something at 0.05, meaning that all the values above it, you can still reject it. But below it, you can't tell if you reject it or not. Okay. You can't tell straightforward if you reject it or not. Unless you do your computation or whatever. Okay. So if you are rejecting something at 5%, then at 10%, it will still be rejected. It will always be rejected. So the answer for this is A. So that is the end of this for now. Okay. Please do well to subscribe to my YouTube channel so that you can watch more of this. Thank you for your time.